You look up at the sky, it is the sky show created by our big hot ball, which is captivating because of its popping red, blue, green, and purple lights visible in the northern regions of the globe. So you might be asking what's the difference between the lights which you see in the North Pole and in the South Pole. So obviously, their names obviously differ. The lights which we see in the North Pole called Aurora borealis, and then the lights which you see in the South Pole are called Aurora australis. So they have quite complicated names, but they're quite similar. The only difference is in their color, and also the northern lights are actually more popular than the southern lights because more people live in the north, near the North Pole, but very few people live in the South Pole in Antarctic regions. So the northern lights are more common and way more popular. Let me explain you how the auroras actually work and the science behind it. Okay, so before knowing it, you need to know what are actually causing these auroras. So the solar winds, our sun contains lots of hydrogen and helium, but these atoms of hydrogen and helium are actually under huge pressure and high temperatures. They actually break up and they are not actually in good shape. The protons and electrons get separated and they are all like moving around and it's all a mess. And this happens in the cornea, which is like the hottest, which happens in the cornea of the sun, which is the outermost layer of the sun. And these electrons and protons from the atoms actually get separated and they move around, creating a lot of mess. Solar winds, which basically pop out from the cornea or the surface of the sun like a bubble, and the bubble or the wind, solar wind, constitutes of these charged protons and actually wiggles around the solar system, moves here and there, and eventually it hits the earth. I'm sure that you're aware of earth's magnetic field, right? So it's kind of like a bar magnet which you have studied in school, and from the North Pole to the South Pole. The Earth's magnetosphere. The Earth's magnetosphere is kind of like the ozone layer. The ozone layer protects us from the UV rays of the sun, and the Earth's magnetosphere or the Earth's magnetic field protects the Earth from the solar wind. And so these solar winds, I'm telling you, they actually move around and they are like moving around here and there in the solar system. They're not actually going like a straight path like how light travels. Light just travels straight, but the solar winds, they are not light particles. They are just like a cloud of, you can say a cloud or like a bubble which moves like a wind and has positively charged protons and neutrons. Neutrons are neutral. It has a charge. They have protons. And then they eventually hit the Earth's magnetic field. So most of the time what happens is that our Earth's magnetic field is strong enough to actually protect us and defend itself from the solar winds. But sometimes solar winds are actually very strong, and when they hit the Earth's magnetosphere, what happens is that it ruptures the magnetic field lines and then puts stress on it, which actually causes to interact with the ions and the atoms present in the Earth's atmosphere. And this usually happens near the poles because that's where the field lines meet and they actually converge. That's where the field lines converge. So that's the reason why you see the lights, the auroras near the poles. Coloring of the auroras. So let's talk about the coloring of the auroras. So these solar winds are hitting Earth's magnetic field and eventually interacting with the Earth's atmosphere. And when it interacts with atoms like oxygen and nitrogen, what happens is that it produces colors. So the charged particles of the solar wind hits the atoms of oxygen and nitrogen, different colors are seen. That's why you see these northern lights, and yeah, they're quite beautiful. So it produces like green and red lights when it hits oxygen, and when it hits and charges the nitrogen atoms, produces like purplish and bluish hue. And that's why you see like the auroras are differently colored, because the composition of nitrogen and oxygen is obviously different in the atmosphere all the time. So the solar winds actually follow the path of the magnetic field. They follow it in like a circular motion, and these circular motions create like that curtain-like patterns which you see in the sky. You might be asking, wait, the auroras are actually something good, right? It's like it creates attraction, it creates site for tourism, but also they are not so good because they actually interrupt communication. As you know, the solar winds are charged particles, and the charged particles interrupts the electromagnetic waves which we use to communicate. By we have communication problems when we all see these light shows in the sky. So hopefully you understood the science behind the auroras, and unfortunately I'm not living near the poles, so I won't be able to see the auroras or the northern lights. So enjoy the northern lights, but don't forget to subscribe.